In the next few minutes, I'll cover the features and the build process to the IoT reference platform product that was developed by Embedded Access. When creating an IoT application, we start with what we call the Embedded Sensor Framework, which is an application that runs in your PC. It is here that you'll define all of the data that you want exposed to the IoT protocols, and you'll configure your system. As you noticed, the application has a number of tabs across the top for various groups of data to set. For starters, you can enable a variety of connection interfaces to your system. For a wired network, you'd enter the typical parameters such as IP address, subnet mask, and gateway. The same is true for wireless connections if you want to enable that, but you can also enable a Modbus interface, and for this you can customize the address and communication parameters. Next, we can take a look at the management of the protocols you can enable. If you want to use SNMP, the MIB will automatically be generated using the trap addressing and parameters you define. Emails can be sent to a specific SMTP server if you provide the coordinates and login information for the target mail server. You can specify which time server to access, and if you would like the web pages to be secured with SSL. The last protocol you can enable is communication to a third-party cloud server hosted by ThingSpeak. This is where you specify a specific channel that you are using, and we'll see in a moment how you can have selected parameters of your system periodically pushed to a cloud server. Under the Modules tab is where you enable the alarm feature and the logging feature, and you can specify different authorization levels for accessing all of the parameters available in the system. For example, this will allow you to control if the user can see and modify certain parameters, or if you have to have admin or factory level privileges. Under the I/O tab is where you can enable the various analog and digital inputs and outputs that are available in your BSP. The same is true for GPIO pins, or alternatively, you can map an I/O already defined in the BSP by giving it a more convenient name, some configuration parameters, and the type of interface it is. The last tab to look at is the App tab, which is where you define all of the parameters of your application code that you want the IoT protocols to have access to. I've entered in a few example entries here, and if you want to add a new one, you simply hit the Add button, give the parameter a name, a description of what it is, an acronym that you can use to access it through the various protocols, the data type, such as Boolean, character, floating, an IP address, or integer. An optional default value for boot up can be added, along with the desired access control and which web page you want this parameter to show up on. You can add as many parameters and web pages as you like, and once you're done, you click the Generate menu. This will do two things for you. All of the web pages will be created and stored in a file system, and it will generate a set of metadata. This metadata is used by the IoT framework to know which data is in your system, where to get it, what to do with it, and to configure the system according to what you entered into this application. We are now ready to switch to our development environment, and for this demo I'm using CodeWarrior, but other tool sets are available as well. I've already imported the IoT reference platform project, and in the source folder are a number of subfolders for things like the metadata we just generated, and the web pages that were generated, which are stored in a readable file system, some configuration files, and there is a placeholder for a main application file, which is where you will put your application code. Typically, people already have an application that they want to drop in, but you can create a new application, of course. For the purposes of this demo, I have an example application that uses the LEDs and push buttons on a K70 tower kit to create the functionality of a typical residential wall thermostat. It uses some sensor get and sensor set functions to give the application access to these parameters. Once I compile and download the application, I can run it and switch over to the web browser. If I enter the IP address that we defined for our system, I get the home page that was generated. We see our two application variables that were defined, the desired temperature and actual temperature. These would be on a different web page if I specified something other than the home page, and as I adjust the potentiometer, the desired temperature is changing. On the config page, I can see the configuration settings for the networking parameters, which you can edit at runtime, and on the I.O. page is the current status of the analog and digital I.O. Finally, the Upload page can be used for updating the firmware. For pushing data to a cloud server, I mentioned that we're using ThingSpeak, and so moving over to this page, I can see that my application is updating a number of internal parameters automatically every 20 seconds. There are a couple of other ways to access the data. You can use Telnet and use a generated set of commands specific to your set of parameters to set or get each value. You can use SNMP via a browser that will access the generated MIB, or if you're familiar with the REST extension to HTTP, you can use this machine-to-machine interface to get or set data. This can be accessed manually using an extension to the Chrome browser, and you simply post or get a value that you're looking for to test it out, but eventually you'll be connecting to a REST server or client who will be interacting with your application. If you set up your system to send alarm emails, those will be generated, and if you want to run test scripts, the Lua scripting language can be used by entering that mode and running a script from the SD card. There is much more to the IoT reference platform, but I'll keep it at this for now. If you'd like further information, please reach out to us and we'd be happy to help. Thanks for watching.